Hello, everybody. My name is Laura, and I'm the chair of this session. This is Stream B on capturing performance. And our first talk this morning is going to be by Ulrich Röijezon and Robert Oek, and I apologize for mispronunciations. We're going to start with a recorded video, and then we'll go to live for questions and comments. So, Felipe, I'll ask for your help, please.
I got it. Okay, so please let me know if the sound is not working. It should work. I'm gonna play the video now.
Hello, my name is Ulrich Röijezon. I'm professor in physiotherapy at Luleå University of Technology in Sweden. I'm doing this presentation together with my colleagues Robert Ek, who is a PhD student, and Federico Visi, who is a PhD, and Stefan Östersjö, who is professor in musical performance. And we will talk about a methodological framework for multimodal and multidisciplinary study of the role of posture and gesture in music performance. And as a short introduction, we know that performing music involves high demands on motor control and sometimes in awkward positions and environments. And the role of posture and movements related to injury has been investigated quite extensively, while less is known about its role on the quality of musical performance. So this presentation proposes a multimodal and multidisciplinary approach to target posture, movement, gesture, embodiment, and music quality among performing artists. The purpose of this presentation is to present a methodological framework for the study of music performance with a particular attention to the role of posture and gesture in relation to the quality of musical performance as well as musicians' well-being. And the presentation will contain 3 pilot studies to support this methodological framework. And the first pilot study is about sitting posture and its effect on movement, behavioral, and musical performance among high-string musicians. And the second study is about method development for multimodal analysis of music performance. And the third is about multimodal analysis of movement qualities in music performance. And I will do a presentation of the first pilot study while my colleagues will present the other 2. So study 1, sitting postures effect on movement, behavioral, and musical performance among high-string musicians. And the aims were to develop a method for assessment of movement behavior and musical quality related to posture in high-string musicians, and to do an initial evaluation of 3D motion of muscle activity and muscle activity of the neck and shoulder, as well as musical quality while playing the violin in different sitting postures. And for this study, we had 1 professional violinist, a male. He was 45 years old, and he performed the same music in 3 different sitting postures. It was his self-chosen posture. We call that neutral, and it was in a slumped position, and it was in a more erect, corrected posture. The violinist played sections of 3 different pieces of music. It was 2 from Mozart's violin concert number 3 and 1 from Bach. And the violinist also played the D minor scale with the frog, with the tip, and with the whole bow. And the measurements during this musical performance was with 3D motion capture analysis of the neck and shoulder, and surface EMG of the neck and shoulder muscles, as well as sound recordings. And the main results from this study was regarding movement behavior was that we could see a reduced range of motion in the forward-backward tilt. The red staples here are the forward-backward tilt, and these two here and these two here are from when playing in neutral as well as erect position, while this red staple here shows the same forward-backward tilt of the scapula in the slump position. So you could see that it's smaller range of motion during the slump position. And regarding the muscle activity, we could see a reduced activity of the and lower trapezius muscles, which you can see here. Upper trapezius and lower trapezius were both lower in the slumped position compared to the other two. And regarding musical quality, these musical recordings were evaluated by the violinist and the professor in conducting. And they both agree that subjectively, the slump position was considered inferior. And they say that the quality was somewhat closed and edgy and more compressed and not as free in the sound. And we also did an objective analysis of the music using spectral analysis. And this showed, you can see the blue line here is the slump position. So this objective measures, the frequency analysis showed that the slump position caused a small peak here in the midsection and also a steeper drop at the high frequencies here. So the conclusion from this pilot study was that regarding movement behavior, a slump position reduced the shoulder range of motion and also the muscle activity of the shoulders. And regarding the quality of musical performance, did the slump position, it was considered inferior by both subjective and objective measures, and the music would be perceived as sounding thinner, sharper, and less brilliant. So these preliminary results indicate that the slumped sitting posture can have negative impact on both movement behavior and musical quality.
The aim of the second study is to better understand how qualitative research methods such as stimulated recall and open coding can be further developed, seeking a consolidated procedure for the inclusion and integration of performance-centered perspectives on musical performance. It constitutes a first step in an attempt to bridging the gap between qualitative and quantitative approaches by combining methods for data collection, with the further purpose of building a data corpus containing multimodal measures linked to high-level subjective observations. Alban Berg's Vier Stücke, Opus 5, performed by two members of Norrbotten Neo, a contemporary music ensemble, was selected as the musical content of the study. The clarinet player, Robert Ek, also a PhD student in the GEM cluster, performed the piece together with pianist Mårten Landström and was then engaged in a qualitative study carried out in a series of steps. To achieve ecological validity, the recordings took place in the Studio Acousticum Concert Hall, a recurring venue for the Norrbotten Neo ensemble. The use of stimulated recall in this study draws on gesture analysis as a component in the coding process, wherein the insider perspective of a performer has been essential. In the adaptation of these methods for the purposes of a multimodal study of music performance, a multi-layered approach was found useful. While a structural analysis could be drawn from the coding process, a more in-depth set of first-person observations were also captured through extended written annotations. Since sound producing and sound facilitating movements of clarinet performance are less visually detectable due to the affordances of the instrument, we opted to record EMG data. This allowed us to capture finger movements and thereby study the role of sound-producing gesture in the segmentation or chunking of the music in the clarinet part. To quantitatively capture a comprehensive view of the movement behavior, we included measurement of kinematics, kinetics, and muscle activity using a mobile movement science lab. We recorded audio and video of each performance. At the same time, we gathered data from 16 inertial sensors, 6 EMG electrodes, and 2 insole pressure sensors worn by the clarinet player. The qualitative analysis was carried out by the clarinetist Robert Ek in interaction with other members of the research team. The analysis followed a series of steps oscillating between first and third person perspectives. An initial process of stimulated recall using open coding had already been carried out on an earlier recording of the same piece. From this process, a series of codes that pertained to movement had emerged through continued recoding carried out through further intersubjective analysis by Ek, Östersjö, Visi, and the choreographer Åsa Unander-Skarin. In the stimulated recall sessions in the second study, the same descriptors were used in the descriptive analysis of movement. The analysis was carried out in 4 steps, out of which the later 3 were designed as stimulated recall sessions using the audio and video recording as stimuli. The first step was to annotate the score and mark phrases, subphrases, and goal points. The second, to make annotations of technical descriptions of movement. Third, analysis of movement qualities using the LMA framework. And fourth, annotations of musical intentions.
Scope of study 2 is limited to data from one single performance. Some observations can be made regarding the method development it explores. We see indications that meaningful data can be drawn from simulated recall interviews with musicians, and further, that a cross-comparison with qualitative data recorded in the same performance may enhance this procedure. More specifically, the results of Study 2 suggest that new perspectives on the role of co-articulation in musical performance, and also the role of embodiment and musical shaping, can be achieved through such combinations of methods. For instance, we find that added value is to be found in reflections on the agency of the instruments and through the socio-cultural perspectives added through the first-person annotations. Important information can be drawn from quantitative measures of movement behavior, that is, kinematics, kinetics, and muscle activity. By combining first-person observations with cross-comparisons of the quantitative data, we found both similarities and contrasts between features. For instance, we noticed how peaks in the jerk data coincided with low amplitude in the RMS loudness, and how this could be understood as an indicator of breathing. We have also observed correspondences between the onsets and offsets of the finger flexors, EMG, and indicators of phrasing in the annotations. Furthermore, we find that the observations of movement qualities made by the clarinetist through the framework of Laban movement analysis are useful in the study of co-articulation, chunking, and segmentation in music performance. A further assessment of how the basic types of gestural sonor objects can be connected to movement qualities in the LMA system is needed. With this aim, we have designed a third sub-project, an ongoing study of the multimodal analysis of movement qualities in music performance. While LMA is a comprehensive system based on bodily action, the theory of gestural sonorous objects extends the study of sound objects by looking at the connections between musician movements and sound. In Study 3, the clarinetist Robert Ek is collaborating with the certified movement analyst Antje Froneman, seeking to further explore these connections between gesture qualities and sound by combining qualitative methods tested in Study 2 with quantitative methods for automated analysis of movement qualities. Audio and video of a performance of the clarinetist are recorded alongside synchronized motion data captured using motion sensors placed in the instrument. The recording is segmented in gestural sonic objects, and the LMA qualities of each object are evaluated by an expert annotator. The recorded sensor data and the LMA annotations are linked using machine learning. The trained model can be used on new data also during the performance, for the purpose of analysis as well as for designing interaction with electronic music systems. The preliminary findings of studies 2 and 3 support the hypothesis that a comprehensive analysis can be achieved through multimodal processing methods applied to quantitative and qualitative data. Work on larger datasets is necessary, and we are therefore planning further data collection involving diverse instrumentalists and instruments.
So, in conclusion, we hope that these 3 pilot studies show the value of combining qualitative and quantitative approaches for data collection and multimodal analysis, and the relation to musical intention, music quality, as well as health. And we predict that this multimodal and multidisciplinary methodology will have impact for several contexts and areas, such as for analysis and development of musical expression and performance among musicians, in learning and teaching situations for students in order to promote skilled movement behavioral and musical performance while minimizing the risk for injury, in ergonomic analysis, as well as assessments of injury risk in future research, and for better prevention and intervention strategies to counteract health conditions among musicians. Thank you.
Okay, thank you very much for that. If you have questions or comments, you're welcome to put them in the chat. You can also raise your hand. And I'm going to start, Ulrich, in the first study with the high ability string players, you found differences between the neutral and correct posture versus the slumped posture. How similar were their neutral postures to the correct posture? Was the violinist already sitting in a very correct posture, or how much change did you have to ask him to make?
Yeah, that's a very good question, because this violinist had a rather, what I would say, a healthy posture as a neutral posture or own posture or own choice. So it would be interesting to have a larger variability between people, and that's the goal for the future research. But they were quite similar, so, and we also saw that in the physiological data, and also in actually also in the music quality, it was also very similar. The violinist himself, they listened to these blinded recordings of the music, so they didn't know what posture, they just heard the music. And both the violinist and the conductor were convinced that the slump was bad. But the violinist himself, he figured the neutral posture better, while the conductor he regarded the directed posture or the corrected posture as the best, and that was from blinded recordings. So that was quite interesting.
Yeah, it was. And so potentially you could see using this almost as a diagnostic tool. Is that part of what the team's long-term approach is in terms of helping diagnose medical problems?
Yeah, well, a big scope would be to show that a healthy posture is also a good posture for musical quality, because posture is always a challenge, whether you work in an office or if you work as a musician. And I think a musician traditionally favors the art. It doesn't. I don't care if it hurts. It's the art. And I think we have to go have another approach to convince that a good posture will also enhance the music quality. That would be the ideal result of this research. And to do that, we have to do a lot of more data collections on a lot of more people. This is just the method development, how we can use multi-data to sort of focus on some area that might be helpful for the musician. Yeah.
So this question could go to either of you. In understanding the stimulated recall in the qualitative data collection, am I understanding that, and I assume this was you, Robert, you were watching your own video and then annotating into some sort of software? Is that how the stimulated, quote unquote, worked?
Yes. We were using the ELAN software for coding. First round of coding was actually just looking at the video and sitting with the score, annotating phrases and goal points and subphrases, kind of the musical structure. And I hadn't looked anything at the quantitative data at that time. So the second part, we moved it to Elan, and I annotated all the movement I saw, not the qualities, but the technicality of movement in different parts of the body. And then into using the Laban framework for motion quality annotation. And then we added the quantitative data and looked for, or not looked for, but just it was really interesting to see. I actually changed I had an idea of the beginning of the piece where I thought this is one phrase, but when I looked at the quantitative data, I realized, no, I'm actually I'm separating it in two phrases. So I had to kind of re-evaluate my own performance, seeing the quantitative data. So that's interesting finding, that when you combine the qualitative and quantitative data, you could get a better understanding of what you are doing when you're performing.
And Felipe?
Yes, I have a question, but I think there is another one in the chat, so maybe I leave the room for that. And if there is time at the end, I can
So the question in the chat, can you describe the differences between the neutral and corrected postures for violin, and how did you determine these?
Okay, yes, so that might be confusing. What I called neutral this time is actually the self-chosen posture. That would be the neutral posture for the violinist, but it could be in a very awkward position. So, but it should be self-chosen. We just asked the person to sit on a stool and play. So that's in this case, what we call neutral, but self-chosen would be better. The corrected posture, we used a method I actually learned from Bronwyn Ackerman, where you turn into a forward tilt of the pelvis, the maximum forward tilt before you sit down. So you stand and make a forward tilt, and then you sit down on your ischial tuberculus and the point below your leg, your thigh. So that would stabilize. You will have a square, and in the middle of that you would have the symphysis above. So that would be sort of the position you sit down in, and from that position you sort of breathe out and you relax, and that will sort of put you in a neutral. So the corrected posture is actually the neutral from a biomechanical point of view. Did that explain these differences?
And it may help people to know, Ulrich, you're a physiotherapist?
Yes, I'm a physiotherapist, yes. So the basic of the correction was from the pelvis and the lower back. And if needed, we could also adjust the shoulders and the neck. But usually when doing this correction, usually that's enough. The rest of the upper body will align. And for this musician, since he had a pretty neutral position in his self-chosen position, he was in an aligned position with help of this pelvic adjustment or correction when sitting down.
Okay, thank you. And then Felipe, do you want to give us our last question?
Thank you. So I was wondering, at one point of the presentation, you said one of the studies, you said that there was a relation between EMG, so the activity of the flexor muscles of the fingers, and some musical parameters that were written in the score, or musical parameters related to musical expression. I don't remember exactly the term. So I just wanted to know if you could give us maybe more details about that. What were these musical parameters? Or
Yes. Can I share screen? Would that work? Let me see. Okay. Let's can see if I find the right. So you can here see data in Elan. Yeah, this one is here. You can see EMG from.
That's actually the jerk.
That's the jerk. Yes. Sorry. It's good you're here. Where do we have the EMG? But the jerk values, aren't they from the EMG? Or?
No, they from the
Here's the
IMU system. Yeah.
Yeah, here's the finger flex.
Yes.
Yes.
So that's root mean squared EMG. It's processed EMG. Yeah.
Yeah. So here you can see that I've aligned with the finger flex motions with the phrasing, and you can see similarities in the intensity of music and, of course, the finger flex. So you can, of course, then see the different hands and how much I'm working with this. With these different different hands and the intensity of movement and if it's okay, I'm just going to show the jerk as well. Because
actually, I'm sorry, Robert. It's 10:28, so we do need to move us on to the next person. But thank you, both of you, and to your team. There's a lot of interesting ideas I think that we can all work with in terms of approaching research questions from different analysis perspectives. So
Thank
next
you.
we're going to let Catherine Liley kind of get in her headspace to present.
sorry, I'll do it again.
Oh, that's okay. We have 2 minutes to allow for tech changes.
Okay. Can you all see my screen, like the full screen? Okay.
So our next presentation will be coming from Catherine Liley, and she's going to be presenting her presentation via recording, and then we'll go live for questions afterwards. And you're welcome to also put your questions in the chat during the session if you're afraid you might forget them. So Felipe, I'll turn it over to you. Thank you.
My name is Catherine Liley, and my paper is called Strength and the Symbolic Universe: Cultural Values, Occupational Health, and Piano Technique Pedagogy. In around 1912, a prominent piano teacher expressed his disapproval of a new approach to piano technique in the following words. "Is this not the very style and method of every unregenerate son of Adam, when he comes to his first lesson with a bunch of feeble fingers, all moving together if one is moved?" The new approach he was referring to rejected traditional technical training, which focused primarily on strengthening the fingers, at least partially on the grounds that finger strengthening exercises caused occupational injury. More than a century later, occupational injury is very much still with us. It affects between 26 and 93% of piano players, according to recent studies. And this is despite all the medical research done in this area over the last 30 years. Approaches to piano technique which involve attempts to strengthen the fingers are also still with us. And when they're challenged, some people still get unbelievably angry. What I'm going to suggest in this paper is that strength-based approaches to piano technique may be persisting, despite the possibility that they cause injury, because they align with some of the most fundamental values of our culture, and that challenges to these approaches may be perceived as a threat to those values, and perhaps even to the way we define reality itself. So to explain the background to this, there's been a huge increase in interest in musicians' occupational musculoskeletal health over the last 3 decades or so. We now have a dedicated research field, health programs in conservatoires, advice for musicians on how to avoid playing-related injury, and so on. The current paradigm in this field views the playing of musical instruments, including the piano, as physically demanding. Flowing from this, advice given to musicians on avoiding occupational injury is based on an analogy with sports. It emphasizes warm-ups before playing, breaks during practice, limiting practice hours, exercising to build strength and stamina, and so on. Traditional approaches to piano technique also see piano playing as physically strenuous, and typically aim to build the pianist's strength, endurance, and flexibility. As already mentioned, there's a particular emphasis on strengthening the fingers. Today, such approaches may include concepts such as muscular relaxation and coordination, in addition to strengthening and stretching. Many pedagogues now also advocate medically recommended injury prevention strategies, such as warm-ups and breaks. But despite all these efforts, pianists are still getting injured. And after 3 decades of research, there is still limited evidential support for the sports analogy on which most injury prevention advice is based. For example, there seems to be no consistent association between playing-related injury and amount of time spent practicing, or any consistent evidence of a protective effect of warm-ups, breaks, or exercise. But a small number of piano pedagogues have continued to argue that traditional technical training is the true cause of pianists' occupational injuries, as well as skill development problems. They've developed alternative technical methods, essentially based on coordination instead of, rather than in addition to, strengthening and stretching. Some of these methods have had extraordinary anecdotal success in occupational injury rehabilitation. For example, those developed by Abby Whiteside and Dorothy Taubman, among others. But their work has been more or less overlooked by medical professionals researching musicians' injuries. Within the piano world, some elements derived from their methods, such as arm weight, relaxation, and coordination, have been added on to traditional training. So, for example, relaxed arm weight may be advocated for playing chords, alongside the development of finger strength for passage work. But these methods in their pure form have continued to be received with hostility by some. So why is this? Why are some people so upset when finger strength training is challenged? And why has it barely been questioned by medical researchers? After all, biomechanical studies have found that more advanced pianists use less muscular effort when playing than less advanced pianists. Strengthening exercises which involve lifting the fingers high are problematic for anatomical reasons, and the occurrence of pianistic virtuosity outside the physical prime of life, i.e. child prodigies and elderly performers, also calls the need for strength into question. While arguably an approach which positions piano playing as strenuous and involves training the body towards greater strength and flexibility, does align with certain Western cultural values, in particular those around hard work, disciplining the body, and the priority of masculine characteristics, like strength, over those deemed feminine, like weakness. Challenges to this technical approach may then be perceived, on some level, as challenges to these values. So this study took a sociology of knowledge view of the problem. Very briefly, the sociology of knowledge contends that knowledge isn't pure. It develops within a society and has a relationship with that society. Recognition of this actually goes back as far as the Enlightenment. As expressed by Pascal in 1670, 3 degrees of latitude upset the whole of jurisprudence, and 1 meridian determines what is true. Interest in the relationship between knowledge and society grew enormously in the later 20th century, particularly in relation to medical knowledge and the sciences. This area of work could be summarized by the title of Stephen Shapin's book published in 2010, Never Pure: Historical Studies of Science as if it was produced by people with bodies situated in time, space, culture and society, and struggling for credibility and authority. What I was aiming to do was to apply this kind of lens to piano playing via an investigation of the way cultural values were manifesting in writing about piano technique. So 15 recent articles on piano technique were randomly selected from piano magazines published in the UK and the US. They were examined qualitatively using discourse analysis, which has been described as the search for patterns within language in use. Discourse analysis can take many forms, but the process I used had 3 stages, essentially looking at what was said, i.e. topics of discussion, how it was said, what kind of language was used, and then interpretation of the results of the first 2 stages in terms of Western cultural values, with the body, gender, and hard work as fuzzy lenses. Most of the articles in the dataset were written by prominent piano pedagogues, and they offer advice on or discussion around one or more aspects of technique. A wide range of technical issues are covered, including various technical tasks, scales, thirds, octaves, and so on, hand position, whole body coordination, practice strategies, the possibility or not of tone colors on the piano, and hand size and shape in relation to technique. One article, Article 10, includes discussion of the work of Abby Whiteside and Dorothy Taubman, who, as already mentioned, have argued against finger strength training. Articles will be referred to by their article number as given in this list from now on. Coding by topic of discussion produced the results shown here. Perhaps the most obvious thing in relation to occupational injury is that there's a high level of awareness of this topic in the dataset. It's referred to in 10 of the 15 articles. Linguistically, there's a lot of use of the word healthy in some of the articles. For example, healthy technical principles, healthy octave playing, healthy sensation of weightlessness, healthy relaxation, healthy, comfortable practice, and even a healthy and expanding diet of scales. Technique is mentioned as an injury risk factor, and the overall approach to technique taken by the dataset is clearly aimed at avoiding playing-related discomfort. Statements on physical aspects of technique advocate relaxation and freedom, coordination and alignment, physical awareness, and the avoidance of tension and stiffness. Nevertheless, mentions of strength, stamina, and firmness appear in the highest number of articles, 14 out of the 15, and the parts of the body they're most frequently applied to are the fingers. There are references to working on strong fingers, developing speed, strength, and endurance as a sporty aesthetic, and building up muscle power and pianistic brawn. Only one of the articles actually mentions that there have been challenges to finger strength training, and it defends it against those challenges. I'm going to suggest that looking at this article through the lens of a particular sociology of knowledge theory could indicate how this might relate to cultural values. In the 1960s, Peter Berger and Thomas Luckman argued that every human society has a symbolic universe. Within the symbolic universe, all knowledge, including the everyday, has its place in relation to a general theory of humanity and the cosmos. But human societies being fragile, symbolic universes need to be maintained against ideas that threaten them. A heretical idea could develop into an alternative version of reality. This is not just a theoretical threat to the symbolic universe, but also a practical threat to the institutions it legitimizes. The result is that conceptions and practices may persist, not because they actually work, but because they fit into and don't threaten the symbolic universe. Symbolic universe maintaining apparatuses include mythology, theology, philosophy, and science, while tools for dealing with threats include therapy and annihilation. I'm going to suggest that two types of annihilation described by Berger and Luckman appear in this article, and one of these is relevant to the rest of the dataset as well. Berger and Luckman argue that one way of dealing with a threat posed by an alternative definition of reality is to assign a negative or inferior ontological status to it. More simply, this means suggesting that those who believe in the alternative definition of reality are in some way bad or stupid. This is what Article 10 begins by doing. Using highly descriptive language, the article imagines a meeting between Abby Whiteside, Dorothy Taubman, and Charles-Louis Hanon. Hanon being the 19th century author of a book of traditional finger strengthening exercises still in use today. In this fictional encounter, Hanon is walking near his home in northern France when he bumps into two American ladies. They all go into a cafe to discuss their work, where it turns out that the views of these two Americans couldn't be more different from the respected and respectable Frenchman who sits before them. Whiteside tells Hanon his exercises are the problem, not the solution, and then loudly explains and physically demonstrates her theories, despite nervous looks from other people in the cafe. The article goes on. Hanon, now determined to face down this brash American, flexes his fingers in readiness for his exercise number 1, keen to demonstrate how dexterous fingers are the natural servants of the music. Alas, before he can strike the first of his imaginary notes, he's interrupted by the other lady, emboldened by her friend's theatrics. So Whiteside and Taubman are portrayed here as unwelcome foreign intruders, brash Americans who are disrespectful of European traditions. This casts suspicion on their technical approaches, particularly their arguments against the tradition of finger strength training. The article then moves on to another type of annihilation described by Berger and Luckman. This is where an orthodoxy incorporates a deviant belief into its own system in order ultimately to neutralize it, or in different words, liquidation by merger. The article advocates a compromise, or merger, in which finger strengthening exercises are retained but with various caveats. They're to be played with mental and musical engagement, and the focus is not to be confined entirely to the fingers. As already described, the dataset as a whole essentially takes this technical approach. Finger strength training is retained, while concepts like relaxation and coordination are merged with it. So why would finger strength be so important within our symbolic universe that it requires this kind of defense? Well, within our culture, the concept of strength has connotations of masculinity and also of physical effort. Challenges to the need for strength may therefore propose a version of reality in which it's possible to do something well without hard work and the development of masculine attributes. This may pose a particular problem when it comes to piano playing, due to the already uncertain position of music and the piano in our society in relation to gender. Music and musicians have been seen as feminine within Western culture for many centuries. This has been linked in some contexts to perceptions of music as dangerous, but in others to it being peripheral, trivial, and decorative. Within education, music is still considered a feminine subject, and some boys who participate in it suffer homophobic bullying as a result. Keyboard instruments have had particularly feminine connotations historically. Studies still show the piano ranked as a female instrument, and more girls than boys take piano lessons. It's been argued that these kind of perceptions have led male musicians to try to masculinize music. This has included the use of heroic, male-centered narrative forms in classical composition, and an exclusive focus on the rational and objective in musicology. So my suggestion is that something similar could be happening in relation to piano playing. The continued use of finger strength training for pianists may therefore not only defend the symbolic universe of our culture, but also bolster pianists' position within it by warding off associations with femininity. Indeed, it was suggested by a prominent piano pedagogue in 2003 that arm weight methods had emasculated the natural power of the fingers. Of course, it's understandable that this is happening in the context of our culture. Nevertheless, the consequences could be damaging. Descriptions of playing-related pain and skill development problems within the dataset for this study suggest that the merger technical approach advocated in the articles may not be a complete success. There are still sluggish and clumsy hands, and fingers which apparently refuse to do what we want them to do. Many players still have excessive tension in their wrists and forearms, and I think most tellingly of all, one article admits that for most pianists, virtuosity remains elusive. My conclusion then is that it may be necessary to think outside the values of our culture in order to improve pianists' occupational musculoskeletal health. Thank you for listening. These are my references.
Thank you, Catherine, for that very interesting talk. I'll pause a moment for other people if they have questions or comments. And I'm going to assume that not everybody in our audience has an extensive pianist background. Can you say a little bit more about how finger strength is being talked about in the community of pianists? Are we talking about just the force that you push a key down, or?
It's often a bit unclear, actually. So there's often a general idea that you need finger strength, but it's not entirely clear what it means. It's often not defined beyond ability to do. So if someone is playing well, particularly with passage work, where there's lots of notes like that, they may well be just considered to have, good finger strength. And if someone's struggling, they may be considered not to have finger strength and be sort of exhorted to strengthen their fingers. But often it's not clear. I mean, with, say, in dance or sport, very often people know exactly which muscles need to be strengthened or stretched. So maybe the hamstrings need to be stretched or something like that. But often in piano playing, it's just you need strong fingers or you need independent fingers. That's another one. And again, it's not defined anatomically at all. Students are just given all these exercises, which often involve lifting the fingers high and sort of doing things like this. And it's not actually clear what's the attempt to sort of, I don't know, what they're trying to achieve, I suppose, in a physical sense. So it's a very confusing thing there, and it's often considered very important, but it's not always clearly defined, if that makes sense.
It definitely makes sense, because exercises like hand, and I tend to think of them more for dexterity, was sort of how I was given them. And so perhaps for the field, I mean, it sounds like this is a topic that could be explored in itself also, is just what do we mean by finger strength?
Yeah.
And perhaps even where that term was first used came out of a more masculine tradition. I mean, maybe the roots do go all the way back.
Yeah.
It came across that.
It seems to go back a long way. I mean, or sort of, again, depending on what it actually meant. I mean, it's said that J.S. Bach did some sort of exercises to make his fingers equally strong. And then, as you go forward in sort of keyboard history, it pops up again and again and again. And then in the 19th century, you get really this huge volume of exercises coming from the printing press, volumes and volumes and volumes of technical exercises. Not all of them are aimed at strength. There's stretching as well, but a very big emphasis on those kind of aspects of technique.
So coming from the chat, from Shirley Wu, there exists now tools and accessories to increase physical finger strength. Is there any research in this area, rather than, are these tools recommended or not? Yeah, have they been studied?
Not that I'm aware of, no, not in piano playing. And actually going back historically, in the 19th century particularly, there were a lot of devices for increasing finger strength. All sorts of things there were some things where you just put your arm in and it sort of trapped your arm there so that you couldn't move the arm and you were just using the fingers. So there was a lot of that going on in that era. But most of that's fallen out of favor now for piano playing. I'm aware that there are things for strengthening people's hands if they've had ill health or, within the health area, but not particularly in piano playing. Those things kind of, the old kind of the 19th century devices, they tend to be frowned upon now. So, it's bad that people use those, they cause injury. We shouldn't use those, but the exercises carry on. So there's this kind of, we're modifying things and we're thinking about health a lot more, but we can't let go of the idea of strength, of finger strength, I guess.
It's something that I found in my own teaching and observing teachers is, this idea of repetition, and like it's that physical thing you're talking about coming from sport, that you need to do things lots and lots of times to be strong, and we want to emulate that. So your theme definitely resonates with me. And then a comment from Flora: the language that teachers use to describe movements and sounds can hinder or help students. Strength does not seem a good word to guide someone through the desired technique or sound. which
Yeah.
seems to come back to the inconsistency in how it's used, maybe.
Yeah, and I think lots of individual teachers, of course, use terms differently, but lots of published teachers do as well. So you get people writing books on technique, articles on technique, and lots of terms don't necessarily match with each other. So there can be a lot of talking at cross purposes around that as well.
And then and follow up from Shirley Wu, what about alternative sized keyboards for pianists?
Yeah, I think there's some work been done on those, and they definitely do help some people having a smaller keyboard. I wouldn't necessarily see those as a full answer, because somebody might not necessarily change their technique if their technique is causing a problem. I mean, for example, in my case, I can't stretch a tenth, but if I had a slightly smaller keyboard or I could just stretch a tenth, I might feel obliged to try and stretch a tenth and push my hand really far. So there are those kind of problems. It might depend what your problems are. So I think, yeah, they're something that's good and that help people with certain things, but may not be a full answer to the issue of injury.
Okay, and we're just a couple minutes left in the session, so I think we'll bring it to a close here.
Okay, thank you.
Thank you very much. It was it's nice to hear a different perspective in terms of sociology of knowledge, and I appreciate you.
Thank you. Thanks.
So we'll pause here for a moment and let Felipe. We're not doing video, that's right. So Emma, go ahead and start sharing your slides, but we won't actually start till 10 o'clock.
Can you see my slides now?
Yes, we can.
Great.
So we'll wait 2 more minutes and then we'll let Emma get started. It's 11 o'clock, so we're going to move to our last presentation in this session. So Emma Allingham, I'll let you begin your presentation.
Great, thank you very much. I'll just check that you can hear me. Yeah. Okay, so hi everyone. Thank you very much for being here to hear my presentation. My name's Emma Allingham. I'm currently a third-year PhD researcher at the University of Hamburg, where I'm working in the ERC-funded project SLOMO. My supervisor is Professor Clemens Wilna, and on this particular study, I was also very happy to collaborate with Dr. Brigitte Berger. So today I'm going to present to you some of my PhD work on effects of attentional focus in violin tone production. So the study I'm presenting today was recently published in Journal of New Music Research. And if anyone would like to read the paper and has issues accessing it, please just send me an email and I would be very happy to share the paper with you. So the motivation for this study came from thinking about what is the optimal state of mind for performance under pressure and how can we apply knowledge of performance psychology to a music performance context. One area of research which addresses these questions is research on focus of attention in motor skill performance. So how is motor skill performance affected by what the performer is thinking about? And I should just mention that it's really great for me to have Laura Stambaugh here as the chair today because she also has conducted research in this area. So to illustrate a little bit what this experimental paradigm is all about, I'd like you for a moment to imagine that you are going to practice some baseball skills. So you're holding a baseball bat in your hands, someone's about to throw a ball towards you and you're going to try and hit the ball. On your first attempt, I'm going to give you an instruction. Focus your attention on your arm movement. On your second attempt, I'm going to give you a different instruction. Focus your attention on the swing of the bat. So according to research on attentional focus, one of these instructions should optimize your performance relative to the other. So the first instruction I gave you to focus your attention on the arm movement is what we would call an internal focus of attention, in that your attention has been directed to internal body movement mechanisms. The second instruction to focus on the bat is what we would call an external focus of attention. So here your attention is put outside of the body onto the environmental effects of the action. So another example might have been focus on the ball or focus on where you want the ball to go. Research on attentional focus has broadly shown that an internal focus tends to impair motor skill performance relative to an external focus. There is some disparity in findings on this, but broadly, this effect is quite robustly replicated in many different types of motor skill, mostly in a sports performance context. And this effect is sometimes known as paralysis by analysis, which is a phrase which quite nicely captures this idea that the harder you think about how to do an action, the harder it becomes to actually do the action well. So taking our baseball example from before, it was the second one, focus on the swing of the bat, that should, according to the literature, improve your performance. Observation of these attentional focus effects have led to the constrained action hypothesis, which predicts that an internal focus instruction tends to impair motor performance relative to an external focus instruction. And the mechanisms behind these effects are thought to be that bringing conscious attention to motor control processes disrupts automaticity, and this tends to impair performance. It's also been shown that an internal focus tends to cause higher muscle activity or less efficient muscle use, providing evidence for the constrained action hypothesis on a physiological level. And constrained action effects may apply to both experts and beginners. There is some disagreement in the literature about this. And finally, constrained action effects may also apply to the learning process as well to the performance of pre-learned skills as well. Looking at focus of attention in music, in a musical context, this is still somewhat of an emerging field with only a handful of published studies having applied this paradigm to a musical context. Some evidence for the constrained action hypothesis does exist in musical tasks. So Duke, Cash and Allen were the first to show this in a simple keyboard playing task. Two studies from Atkins also support constrained action effects in singing tasks. And a recent study from Mornell and Wolf supported the constrained action hypothesis in expressive music performance in a sample of multi-instrumentalists. On the other hand, 2 studies from Stambaugh found no evidence in support of constrained action effects in the music learning process of woodwind and brass playing, and this was looking at skill, retention, and transfer effects. So Stambaugh suggested that tactile feedback may be particularly important in learning to play an instrument, and that this may be causing us to see some differing effects between musical tasks and sports tasks. So for example, an internal instruction which brings attention to the body might cause a musician to start focusing on feeling vibrations or tensions in the instrument, and this might actually improve their performance. This idea could be connected with processes behind somatic training methods, such as the Alexander technique and the Feldenkrais method, which are commonly used in music education and which might typically encourage a musician to think about or become aware of body sensations, such as feeling vibrations or feeling the sensations of movement. So we were particularly interested in how focusing on tactile feedback might affect performance. So we aim to look at effects of focus of attention in a violin tone production task. We thought this task would be an interesting context for this paradigm because it's a complex motor skill requiring the careful balancing of several control parameters. We wanted to see how effects might be different between experienced and novice players. And we wanted to see how focusing on tactile feedback might affect performance. And finally, we wanted to look at performance outcomes at the physiological, physical, and acoustical levels of performance. So these are the instructions we used in our experiment. The first one is the internal focus instruction, bringing attention to arm movement. The second is an external instruction, bringing attention to the sound, and this is something that's been commonly used in music studies on focus of attention before. And the third one is another type of external instruction, which we have called the somatic focus. And the aim of this instruction was to bring attention to tactile feedback from the violin bow. So focus on the resistance of the bow against the string. We had 32 participants, half of whom were complete novices to string playing and half who were experienced upper strings players. And they performed a simple tone production task after a short training period. And the task was to play 4 even notes in response to a metronome on an open string with the aim of producing a good sound. And here's a short example of what it sounded like. All participants performed under all 3 focus instructions in a repeated measures design, and the order of these instructions was counterbalanced across participants. You can see in the lower picture on the left, participants were outfitted with wireless EMG sensors measuring muscle activity in 3 muscles of the bowing arm. And then in the upper picture, you can see they were also wearing motion capture jackets with markers placed on their body and on the instrument. Although we collected motion data from the body, in the current study, we only analyze the motion data from the violin and bow. So these are the outcome measures that we analyzed. So at the acoustic level, we have 3 acoustic features measuring aspects of the timbre of the sound. At the physiological level, through EMG, we measured activity in the bicep, triceps, and deltoid muscles. And at the physical level, using optical motion capture, we measured side-to-side sway of the violin, bow acceleration, and bow contact point, which means the positioning of where the bow was placed on the string. All of these measures were analysed with a 2-way ANOVA with factors, focus condition, and expertise. So moving on to the results. Does focus of attention affect tone quality? We found that the answer was yes for one of our acoustic measures, and this measure was spectral centroid. So there was a significantly higher spectral centroid under the somatic focus compared to the internal focus. This acoustic feature is generally considered a measure of the perceptual brightness of a tone, and previous research has shown that brighter tones in violin playing tend to be considered better quality. So we can interpret this result as an improvement to tone quality when they were under the somatic focus compared to the internal focus. Interestingly, we don't see any difference between the internal focus and the external focus on sound. So this improvement in the somatic focus is in line with the constrained action hypothesis, but the lack of a difference between the internal and the external sound focus is not. There were no effects on the other two acoustic measures, and there was no expertise interaction. Next, does focus of attention affect muscle activity? We did find an effect of focus instruction for the deltoid muscle. So you can see in the graph on the left. Again, here we have a difference between the internal and the somatic focus, with higher muscle activity in the internal focus relative to somatic. And this higher muscle activity might indicate less efficient muscle use. So this is in line with previous studies on the physiological effects of constrained action, although again, no difference between the internal and external sound focus. For the bicep, there was no significant effect. For the triceps, there was a significant main effect, but no significant effects in the post hocs after Bonferroni correction. So no real effect there in the bicep and tricep, but you can see that the trend is somewhat similar with higher activity in the internal focus. And again, there was no expertise interaction. Does focus of attention affect bow motion? So this time we saw an effect for our measure of bow contact points. So here, this is the standard deviation of the positioning of the bow on the string. And pedagogically speaking, a higher standard deviation indicates more variability and therefore poorer bow control, less kind of consistent technique. So what we see here is lower standard deviation or improved bow control in the somatic focus, this time relative to the external focus on sound. And this was an unexpected finding because really we were looking for differences relative to the internal focus. But this seems to indicate a motor control benefit of the somatic focus, focusing on the bowstring resistance compared to focusing on the sound. There was no expertise interaction here again, and there were no significant effects for bow acceleration. Finally, does focus of attention affect instrument motion? So this measure is the side-to-side sway of the violin itself. Pedagogically speaking, we consider increases in sway to be an improvement, to show kind of less stiff, less rigid body posture overall. And these are only very small micro increases here, so there's no very big disruptive motions happening here. What we see here this time is a difference between the novices and the experienced players. So for the experienced players, there was no significant effect of the focus instructions, but for the novices, we again see a difference between internal and somatic focuses, with an improvement in the somatic focus shown through small increases in violin sway. There was also a main effect of expertise, with the experienced players showing overall higher sway than the novices. So overall, our results show partial support for the constrained action hypothesis in the context of a violin tone production task, and this is in line with previous literature. We saw this through a general performance benefit of the somatic focus on bowstring resistance, or tactile feedback as we have conceptualized it, compared to the internal focus on arm movements. And we saw this in terms of improved tone brightness through spectral centroids, decrease in deltoid muscle activity, and for the novices, slight increases in violin scroll sway. We also observed a benefit of the somatic focus over the external focus on sound in terms of improved bow control through less variable bow contact points. We saw no benefits of the external focus on sound, and this is in contrast to some previous findings of focus of attention in music. One potential influential factor here is the complex technical nature of the violin tone production task. And this idea of task complexity interacting with focus of attention is something that was suggested by Laura Stambaugh as a potentially influential. So more complex tasks may be less highly automated than simpler tasks, and therefore may still require some element of conscious control. And in this case, a focus such as the somatic focus in our study may have provided the performer with the ability to still consciously think about movement technique, but at the same time diverted their attention away from their internal body movement mechanisms per se. And this idea is in line with a recent study from Singh and Wolf, who found that beginner volleyball players whose movements were not yet highly automated benefited from a focus of attention on a movement metaphor, which on the one hand brought their attention away from their own body movement control per se, but allowed them to still think about movement technique rather than, say, a focus which was maybe one step removed from the movement technique. So for example, in our study, the focus on sound is kind of another step removed away from the focus on feeling the bowstring resistance. The benefits of the somatic focus that we observed in this study seem to generally support the idea that attention to tactile sensory feedback might be particularly important for instrumental music playing. We also observed some evidence for the physiological effects of constrained action, and this is supporting previous literature. So further research could be useful looking at links between focus of attention and injury prevention or efficient muscle use. In terms of expertise, most of our effects we observed were independent of expertise, but the violin sway applied only to the novices. So further research is needed, I think, to tease out the complex ways in which expertise may interact with focus of attention in different ways. So in conclusion, our study has shown some evidence in support of the constrained action hypothesis in a violin tone production task, and showing that the state of mind of the performer is important for allowing them to perform well, and that this state of mind can be influenced by just a few words given as a focus of attention instruction. We saw overall that a focus on tactile instrumental feedback through this somatic focus tended to support performance better than a focus on body movement itself, and this could be something useful for pedagogy and for performance practice. And we suggest that further research would be useful on this in this paradigm, applying focus of attention effects to fully expressive musical tasks, factoring in audience perceptions and naturalistic performance environment, and continuing to explore the possible learning effects of attentional focus as well as immediate performance effects. Here are some references, and thank you very much for listening.
Thank you very much for your presentation, Emma. So we'll take a moment and allow questions. I see Clara, you've raised your hand. Go ahead and unmute yourself.
Hi, thank you for your presentation. Just to verify, the task was just the 4 tones, right?
Yes.
So for the beginners, how beginner were they? I'm just wondering, I guess, like, even though you're a beginner, what would be the difference between beginner and experts for?
Yeah, absolutely. Yeah, so the beginners are, I think I've called them novices in the paper. They are complete beginners, so they had never touched a string instrument before, but they were all musicians themselves. So most of our participants came from the university orchestra. Most of them were undergrads and playing in the orchestra, so fairly accomplished musicians, but the novices were complete novices to string technique. And this was something which initially when we were designing the study, my supervisor was keen to look at expertise, and I was skeptical if we could do that, if novices would be able to do this task in such a short period. But we piloted it, and it worked, and they could do it. Of course, it is a short training, so it was a 15 to 20-minute lesson. So yeah, they are very much in the very early stages of this, and they haven't fully learned the task yet. So of course, their movement is not going to be highly automated yet. But I was, pleasantly surprised at what they were able to achieve. And I think because they were musicians, they kind of understood generally what was involved and how to follow some instructions and learn a tone production task. So that was the novices. The experienced players had a minimum of 7 years training. And yeah, most of them were quite accomplished musicians, like I said, playing kind of full repertoire, but not professionals, and most of them were not kind of music conservatoire level musicians either. So yeah, one of the things we mentioned in the paper is that kind of different types of expertise comparison might show different results. Like maybe very, very experienced players would be more differentiated from the novices.
Great, thank you so much.
Next question from Ulrich.
Thank you. Very interesting and ambitious project, and congratulations. And interesting results. I was thinking, when you choose the tactile input or the somatic focus, how did you discuss with yourself and your colleagues to choose what you choose?
Yeah, that's a good question. So I think initially my interest in this topic came from a kind of dissonance I felt with what I was reading in the literature and what I felt to be true from my own personal experience, because like I mentioned, these somatic training methods, I'm experienced with the Alexander technique, which really helped me with my performance. When I was at music college, I studied undergraduate at a music conservatoire as a violinist. And these somatic methods, in my experience, tend to very much ground us in the body. And I think in music pedagogy as well, a lot of the time, or certainly a lot of the pedagogies that I was informed by, are very much promoting, experiencing music through your body and being in the body and being embodied. So then this advice that was coming from this performance psychology literature on that we shouldn't focus inside our body, we should be thinking outside of the body, kind of didn't really sit well with my own experience. So that was kind of how we got to this idea of tactile feedback. And then of course, from Laura's papers, this was something she had mentioned as well, as possibly being influential. So we wanted to have a focus instruction which would achieve a kind of focus which in my mind was the sort of focus that I had experienced doing the Alexander technique, focusing on bow string resistance, which kind of brings you to feeling the tensions in the bow and the changes in tension. So yeah, but we also wanted to word it as an external instruction at the same time, so that it would be not directly referring to the body, which is how this internal instruction is defined in the literature, but at the same time somehow still kind of grounded in bodily experience. So that was the aim. And then, yeah, it was a little complex kind of coming up with the precise wording, because we didn't want to introduce confounds between the focused instructions. We wanted to keep them as straightforward as possible. And yeah, this was where we landed.
Yeah, I was thinking. I'm doing similar things in sports with rods, fishing rods. But I was thinking, could another focus have been sort of bow trajectory? That's what I would use in fly fishing, fly casting teaching situation,
Right.
to have the trajectory of a specific part of the rod as an external focus. Just thinking.
Yeah, I think that's definitely interesting. There are definitely different ways you can bring attention to the bow. For this particular one, I think, yeah, we wanted to think about bow resistance, because the aim was the tone production, and that just seemed like, from my perspective as a violin player, that seemed like a kind of intuitive focus as well. But yeah,
Okay.
absolutely, that would be interesting. I guess if you were measuring kind of other kind of technique parameters like the angle of the bow and things like that, then yeah, some kind of different instruction to focus on the bow would be interesting.
Okay, thank you.
Anna, what's your question?
Wonderful talk. Thank you very much. We actually replicated the study you mentioned, the first study with the pianist recently. It's under review right now. And my question is really directed at the implications for music education, because we also saw some differences between beginners and advanced players in our study, a little bit more than in here. We saw very major differences between them. So what would you say, how would this inform musical pedagogies, like educational tools? How would you instruct someone ideally to to have the right kind of focus?
Yeah, well, that's really interesting about your paper. I'm looking forward to seeing that when it's published. Yeah, I think so. For me, I mean, first of all, I would be careful not to extrapolate too much kind of broad statements from this one study, because, as you know, like we see these small differences in these few studies that exist in music on this effect anyway. And I think individual difference is always important, and this is also something I would love to look at further, like how this might vary across individuals. For me, how I think I would like to translate this to music educators is to think carefully about the words they use, and that the words you use can really have these effects on the state of the mind of the student. And even if maybe even if you're thinking about long-term learning, your words might really affect the student's performance in the moment. So thinking about these differences between in the moment performance and then longer term learning. And I think it could be a kind of useful thing for teachers to try and avoid referring directly to the body and to controlling the movement. Not to say that they should never do that, because maybe sometimes it's necessary, but I mean, personally, in my own teaching, I think that would be a kind of like fairly harmless thing to try out and quite a fun thing to play with. And I think that thinking about sensations and tactile feedback is a really nice way that you can avoid talking too much directly about the body while still having this focus on technique.
Yeah, thanks very much.
I'll go to Alvaro's question, and then Michelle's will be the last one.
Hi, Anna. Thanks for the talk.
You're welcome.
I wonder, do you think the benefits you observed from this particular focus of attention will show in other musical tasks? It has to do a bit with generalizing to other musical tasks.
Yeah. Well, first of all, I would just promote another paper that we have actually, which looked at this in a second bowing task. So that was in Journal of Research in Music Education. And we found very similar results overall. This was I won't go into the bowing task because it's a little bit complicated to describe, but it was a different bowing task, and it was still about about bow control. So yeah, so that's one kind of other addition to the discussion. But yeah, I mean, in terms of different tasks, I think there's just still a lot of work to be done. And really what we've done in this study was very reductionist. And like I said, I think it would be great to look at this in more kind of fully expressive music performance and in realistic settings as well, to kind of really get an idea of how it should and could be applied in different ways. So yeah, I guess the answer is that I don't know, and I think we need to do more work on that. I think personally, something really interesting for violin playing would be to extend this to like intonation tasks, because this is a kind of different skill, but it's still very much a motor control skill. And then when you get to expressive musical performance, I think things get more complicated. There is some evidence supporting that by this paper from Mornell and Wolf, but it's a slightly different, they've conceptualized focus of attention slightly differently in that paper. So it's not, I wouldn't say it's directly comparable, but yeah, we should definitely look at that more before we start saying, you know, musicians should never focus on their body movement.
Thanks.
And then Michelle Manson has asked, do you think that there would be a difference in results if the study were to be replicated with a different instrument that has different performance priorities in sound? For example, you mentioned how brighter sound is seen as more ideal in violin, whereas violists prioritize a more rich sound.
Oh, okay, interesting. Yeah, yeah. I mean, I don't know, but probably, quite possibly. And I think that maybe this is I'm not sure if you would call this a bias or like just a kind of fact of the way the study was designed, is the fact that I am a violin player. So, you know, I selected this focus of attention on bowstring resistance, having an intuition that that would probably be a good focus. So I guess that, yes, these things might differ between different instruments. And I think, especially from your own research, Laura, as well, it's interesting to note that, you know, a focus on sound doesn't always necessarily improve performance over a focus on body movement. So the internal external thing, I think, is not the whole story, and it's more like the type of focus you have. So there are lots of different ways to make an external focus, and yeah, the particular way that you make that focus is going to be informed by knowledge of how to play the instrument from the teacher. So yes, absolutely could be different in different contexts.
Okay, well, thank you very much, Emma, for your presentation and for answering all these questions. And I think we are on a break now, so you can check your schedule, and we'll see everybody after break.